All right. All right, so we're going to give this is kind of a brief overview of the agenda we're going to go through. I'm going to give a quick update on the SAS SATA device specification that we contributed earlier this year. And then Lee's going to go over the data center NVMe 2.5 update that we are any second now going to be contributing. And then we're going to do a customer perspectives panel. All right, so let's jump into the SAS SATA spec update. So first I want to start off with kind of just some of the challenges that we had in the industry that led us to go down this road. I think everybody here is very familiar with our industry specs for SAS and SATA. We've got our T10 and T13 and SATA I/O. They're all great, very feature rich, lots of optional features, which sometimes can be problematic because suppliers don't know exactly what they should implement out of all of those optional features. You know, they really want to know what do data center customers actually require. And in the past, there's not really been any open or public customer specs for these SAS SATA devices. So they kind of have to guess or talk to us specifically because we all had our own individual confidential specifications. And so they would often, suppliers would come and talk to us and figure out what each one of us would need, hyperscalers, OEMs. That, of course, results in a lot of problems. It reduces the amount of innovation in the industry because you can't collaborate when you've got a bunch of confidential specifications. Lots of times we would have very, very similar requirements, but they'd be slightly different, and so we'd wind up with different versions of firmware and things that would drive a lot of extra industry work with very limited value. So talking about testing, some of the previous talk earlier about testing was great. One of the challenges we had with testing when this was all confidential and proprietary specifications, of course, was that the third-party test houses didn't know what they should add. We all had to create our own test suites. We had to create a lot of redundancy there, right, because we were testing, again, the vast majority of things were similar. And if you were a third-party test house, you had to figure out, well, what optional features should I include in my test suite? What do the customers really need for testing? And of course, all of that really, again, results in a lack of collaboration, which winds up slowing down innovation across the industry. So we all joined together, Microsoft, HP, and Meta got together and said, this is not good. Well, let's do something better. So we got together and merged all of our requirements into a single specification, which is the OCP Datacenter SAS SATA device spec. We contributed it earlier this year, back in May, and it includes both requirements for hard drive and SSDs. And you can download the 1.0 specification if you go to the contributions database on the OCP website. You click there and you can search for SAS SATA. You'll see the device spec there available, and when you get these slides, you can also click that link that we have embedded. So I talked about some of the problems. Let me talk about some of the benefits of having an open specification. Back to the confidential requirements. That results, of course, in a lot of trade-offs because all the suppliers have very limited resources. And so we would often hear, you know, when we go through a gap analysis with our specs, we would hear customers or suppliers come back and say, well, you know, if you really want to hit the schedule you're trying to hit with this drive launch, you really need to drop this feature or that feature. We can launch it later with a new firmware update, things like that. So if you look over to the right here, I think everybody's kind of familiar with this trade-off triangle in product development. You've got your features, your quality, and your schedule, and typically you can only have 2 out of those 3. And so going to an open specification really reduces a lot of those trade-offs. So now we have consolidated resources in the industry. They're not developing so many different firmware branches. And having these common requirements across multiple really large customers is key to being able to deliver a fewer number of features that are they're all shared across our customer base now, which can really result in getting basically much reduced trade-offs. So you get more features, better quality, and faster time to market now. So let me go through a couple of the benefits. Kind of the one firmware to rule them all is the ultimate goal. Right, we've got our common set of features, means we have fewer custom firmware branches. You know, we've talked to some vendors that have said they were basically maintaining up to or more than 10 different firmware branches for all their different customers. Clearly, that leads to lots of inefficiencies, a lot of redundant resources to develop and test and then maintain all of those different firmware branches. So of course, our ultimate goal is to get to one firmware build kind of that has all of the functional features that we need in our products. Of course, that will allow suppliers to focus their resources on that one firmware, which can really improve the product development and the quality of that firmware and also reduce cost. But we still allow things to be customized somewhat through our build time customizations in our device profiles section. So if one of us needs something like a 4K block size versus a 512 byte, we still have one firmware for that, but that can be at build time, that can be shipped out as a specific customization or profile. And again, this all leads to the more features, better quality, and faster time to market. And now to touch back on testing and see some of the benefits of testing, it's pretty obvious, right? But now that you've got published requirements, that allows third-party test providers to develop really specific test suites on the specific features that we require, that we put into the spec, so they don't have to waste a lot of their development resources on optional features that we aren't using. This, of course, reduces their burden to maintain multiple custom test suites, and of course improves cost. It reduces their development time, and it improves quality overall, which is great. And now both customers and suppliers can reduce, and then this was touched on in one of the previous talks, right? We can reduce a lot of our internal test and validation resources that were kind of duplicative. And now we can repurpose those to go do product development and innovation, which is what we really all want to be doing anyway. So again, leading to more features, better quality, and faster time to market. So I'm going to touch a little bit on some of the things in the spec. Basically, at a really high level, it's just everything you need to know to be able to build a data center SAS SATA hard drive or SSD. A couple of things that we include in the spec are SAS SATA interface requirements, power, reliability, performance specs, environmental requirements. Security, of course, is very critical. Labeling and compliance, and then, of course, sustainability is very important as well. And all of these requirements are sorted by ID numbers so that you can very quickly, if you have a question, you can call out a specific ID number. Easy reference, easy to test to, easy to get questions answered around. A couple of the examples that we have on the interface requirements, for instance, of course, we have our industry standard specs that we all know and love, T10 and T13, so we just specify out which revisions of those specifications need to be included. We go through and we define a lot of the mandatory and the optional features that are in those specs, the log pages and the commands that we need to have in our drives. We have a lot of requirements that cover the PHY and the link and the app layer for those SAS and SATA interfaces. And then we have a lot of general configuration and just operational requirements, things like write cache management, firmware download, which firmware downloads to support, error recovery, SMR configurations, which interface speeds we need supported, and background activities. A couple of the examples on performance and reliability, really what we need for data center performance. So we cover things like latency, IOPS, and bandwidth for data center workloads. We cover, of course, MTBF and AFR requirements that we need, and those are based on workload, temperature, and humidity. And then some of the reliability metrics that we target, load and unload cycles for hard drives specifically, how you handle sudden power loss, data integrity requirements, Uber, and head degradation. And I think that brings us to Lee.
So, as we're all eagerly anticipating the final release of this version 2.5 of the spec, I know I get asked multiple times a day when it's coming out. So it has been reviewed by the now former incubation committee, now steering committee. So the SC did review it last week. It now goes through, I believe, a 10-day kind of waiting period to see if there's any comments against it. And once that's done, if there are no comments or we can quickly resolve the comments, hopefully later next week we will be able to get that put up onto the website. So hooray. So with that, kind of want to walk through some of the things that have been happening over the last few years here with that. OCP 1.0, way back, what, 4 years ago? 5? That was 72 pages, and that was Microsoft and Meta. You know, we kind of, Russ and I came together and said, hey, this would be a great idea. And so obviously that's picked up a lot of momentum in the industry. Because it was a success, Dell and HP wanted it to join in the party. So we released 2.0. It pretty much doubled up to 127 pages. Lots of new stuff around security, especially, and some of the debugging stuff and things like that, and other requirements across the industry. So with that, we are now we're releasing version 2.5 as a last draft. That's kind of the final draft. We think we're about 185 pages, so not quite as much rapid growth as we had before, but we did add Google, and we have some significant new features that we want to talk about with this specification. So some of the key specification growth areas, obviously we've already talked about the telemetry debug stuff, that added 32 pages, so it's a lot of very dense, really interesting, and as Mike went through that, the whole structure of that, how to make it very, very flexible so that we hopefully can really get vendors implementing that and very rapidly do debug both during development and in the field, in the fleet. So some of the other things around security, so we now have a TCG state configuration log, and a lot of times if you're using TCG as your security subsystem on a drive, sometimes the state on that is a little bit, can get out of whack, either through software errors or from drive bugs. And so having this log is a really good way to be able to kind of quickly understand the current state of the device and what needs to be done to recover it. So then we have the error recovery log. This was introduced in 2.0, but we've done some extensions to that to allow for much more seamless error recovery. Of course, security is security. There will always be more security requirements. So we've, I don't know if we doubled the number of requirement IDs in security, but we sure added a lot. And then Ross's favorite subject, flexible data placement. So we added a section now in there that's kind of a if implemented section. So if you implement FDP, then you need to implement it this way. And say maybe in the future, 2.6 or something, maybe there'll be a ZNS section. So if it's if implemented ZNS, then implement it this way. So again, we walk through, here's all the different, we kind of talked around these, and kind of, from high to low in certain sense, telemetry debuggability is, it's just table stakes. Security is table stakes. New use cases, these are things that are up and coming features that we want to be able to take advantage of and be able to use in the fleet as new use cases come online. Obviously, issues at scale, found at scale. As I said before, 1,000,000 to 1 chances happen 9 times out of 10. And so with that, how do we quickly work through some of these things? And then, as we always do with every rev of the spec, there are clarifications and bug fixes, which are great. Lots of people here have given us feedback. We've tried to internalize that feedback and figure out how to better word, or if the value is just plain wrong, we've got to get it fixed and that sort of thing. So I think this one, everybody, we've kind of seen this already a couple of times. Again, the telemetry and the debugging state, I think Mike explained it much better than I could here, but we are really, really, I don't know, excited for this feature. I think, as we started in on this, it was kind of, Vineet and Ross and I had some ideas, and then Chris came on and really, kicked it to the next level with a lot of the FIFO stuff and things like that. So, yeah, enough said. Okay. So, security, yes, we added 25 new security requirements. We kind of want to make a regularization across the NVMe spec and the boot spec and the HDD, SATA SAS HD and SSD spec. So that we want to try and, security, and no matter where we are, we need to be able to have those kind of the same security requirements across any storage, any data-bearing device that we have out there. And then we did a lot of additions and clarifications around using SBDM, so for things like attestation and that sort of thing. So here in the new use cases, we talked about flexible data replacement early in the day, and we added that if implemented section so that in the future, as we add more of these things that maybe not of standard use case, maybe it's used only in storage, maybe it's only used in compute, maybe it's only used for certain other narrow swim lanes or something like that, then that can be added there. And there's issues that we would say we found in the fleet. So some of that things is like mismatches in interpretation in the spec. We wrote it this way, we thought we wrote it clearly. Well, obviously we didn't write it clearly enough. Somebody interpreted it differently, and so how do we close that hole to ensure that everybody, when they read it, they get the same interpretation? Mismatches in implementation. These are things where sometimes, again, if we're not fully specifying something, an implementation can find a loophole and kind of implement it outside of what we intended. And so how do we close that hole and make sure that the implementation will be exactly what we expect? And then in other things, there's things like test escapes. So things that happen where, wow, we thought that was a spectacular new failure mode. I never saw that before. So how do we put that in requirement to close that loophole and then add a test for that so that it doesn't happen again? And finally, the clarification and bug fixes. Questions from suppliers, validation engineers, the engineering groups within the fleet itself, so Microsoft's Azure Compute and Azure Storage folks, and then people just like yourselves. So with that, we're kind of to the panel section.
Okay, we'll go to our panel here. And once we go through the panel, then we will have question and answers. And with that, a few general comments. So we believe that the device specifications in OCP are valuable, and we really encourage everyone to get involved and help increase clarity on requirements. And maintaining SSDs and HDDs at scale is very challenging. There are always areas that need improvement. Telemetry, as we've all talked about, is a big step forward in this area. And then security, sustainability, circularity, these are all important, and they're a work in progress to figure this out. And with that, let's go through each panelist here. Lee, you are up first.
Okay, so what am I talking about here?
Monitor UPHC.
Okay. Capacity scaling while improving maintaining performance density is critical for the cloud. So yes, that's, how do I want to, best way to talk about it. So capacity, there's always a sweet spot for NAND and the lithographies and where we're at with the NAND block sizing. And so with that, going from a 1 terabyte drive to a 2 terabyte drive to a 4 terabyte drive to an 8 terabyte drive, it becomes critical that we don't start to go with your IOPS going. And it may not necessarily have to be on each point, I double the IOPS and double the bandwidth, but it can't kind of flatten off, right? Because then we start to end up, we're in the regime of hard drives, and we end up going to an IOPS wall that we can't take care of. So with that, latency, consistency, and reducing tail latencies. All of our customers actually using these drives, some are kind of like, yeah, whatever, the storage is just doing its thing, and we don't. Others are actually radically adamant about ensuring that the storage is what they thought it was going to be for both the bandwidth, the IOPS, and the latency. And so with that, how do we ensure that through some of the things that we're doing here around all the things that are in the spec and what it's doing, it's not creating issues for tail latencies, it's actually trying to figure out how the best way to tighten those up is. So how can I ensure that my my 5 nines is minimal as possible and as close into the tail. Need for collaboration towards aggressively driving for sustainability, right? Microsoft has some very aggressive goals between carbon neutral and at one point carbon negative, which is basically the idea that we'll have sequestered all the carbon that the company has produced over its entire lifetime. So with that, every single piece of our business has to be cognizant of that sustainability, and how can we get from these devices that are kind of at the end of their life, it's like, you know, well, right now, unfortunately, we have to shred them because of security reasons. So how do we get over the security challenges so that we can get them outside the data center? And then from there, it's like, well, how much of the NAND is left? Is it usable? Is that sellable? Is somebody interested in that? Or does that then, you know, it has to be deconstructed, and how can we get some of the critical components or some of the critical materials back out of that sort of thing? Those are all huge areas for us that we need to keep tracking and start to delve into deeper here at OCP. So, yep.
Okay, next up here we have David Black from Dell EMC.
Thanks. So, common spec avoids pointless divergence. Paul went into this in great detail at the start of the session, so I won't elaborate on that. Have one built for you is something we've all done. It's convenient. It doesn't help the industry. We really need to be diverting those resources to investing in new feature and functionality that actually benefits for the customers. Also, having a common baseline greatly increases the likelihood that the drive on the shelf will just work. Customers, a server go down, they don't have the precise drive they need to replace it, but there's one on the shelf. If everything complies with the OCP spec, there's a real good chance that that drive, when plugged into that server, will get that server back up and running. And finally, Ross sort of touched on this at the start of this panel. We need to have security and sustainability. Security must not be an obstacle to reusing the drive. One of the areas in which I think we have challenging opportunities is the interaction of the need for verifying media after a drive is sanitized to ensure the data is gone interacts very badly with some necessary and important ways that security has been done in hardware controller designs, and there's opportunity going forward to line those up so that we can avoid shredding drives, which Lee also wants to avoid. Over to you, Paul.
Paul, you're next.
All right, so HPE, some of the things that we're kind of looking at that we really see from the industry, there's some, really want to touch on security again and getting comprehensive security. We've got really good security with NVMe drives. We have the ability to do authentication and attestation through SPDM, through the PCI SIG's CMA spec. So we're able to stand kind of on the PCIe interface shoulders from that perspective. But we've got a really big gap right now in our storage security because we don't have anything like that for SAS and SATA. And so there is work ongoing right now in the DMTF SPDM working group. And right now, there's not a lot of folks contributing in there. I don't think there's any device suppliers. So I'd really kind of a little quick call to action to say I'd really love to see more device suppliers participating there so that we can get things like SPDM. There's a storage binding spec, not just for SAS and SATA, but also for when those devices are downstream of like a RAID controller or storage controller, and how do we authenticate those devices so that from a holistic perspective, we have really good security across all the different storage devices that we use and our customers need. One thing that didn't make the slide, but is really important and wanted to bring up here was, and this is really related to FIPS validation for self-encrypting drives, but it really kind of security boundaries that are appropriately sized, so that everybody here knows the challenges that NIST has, right, and how long it's taking to get FIPS validated drives. And so we really want to make sure, and this is a great trend actually that we're seeing, and so we want to really encourage this trend to continue occurring and have more folks do this, but limiting your security boundary, whether that's through a secure enclave or some other technique, but making sure that when you do a firmware update, and there's multiple benefits for this, right? Secure enclave is just great, just from the isolated security plane that it provides. But in addition to that, from an actual product development perspective, it's great because it might allow you to leverage that same secure enclave or FIPS validated module across multiple products, which helps us do time to market much, much quicker. And so I think in general, I just want to say keep that trend up, keep deploying it so that if you get a firmware update and it's non-security related, we don't want that to trigger a full FIPS validation. Right, so all of those things are great reasons why we want to see secure enclaves and that moving forward. Performance, we still see the need to kind of have a better stratification between the high performance swim lanes for NVMe drives and the mainstream class or data center class of NVMe drives. There's still a ton of overlap there in the industry. And what we don't want to see is as we move to PCIe Gen 5 and then eventually PCIe Gen 6, we don't want to see that kind of just get even more blurred. We want to make sure that there's a really good product for our customers who are used to SAS and SATA to easily move into NVMe. And so we don't want to try and move a customer from a 6-watt SATA SSD to a 25-watt NVMe drive, right? That's just not going to make sense for their workload. So we really need to have something so that, because we all want to get customers to fewer interfaces, we want to test fewer interfaces. It'd be great to kind of get the industry, at least from an SSD perspective, to go from SAS and SATA to NVMe. So this is one way that we see doing that. And as we get to the high performance and we're moving from Gen 5 to Gen 6, we really want to see that really push the limits on trying to get maximum performance for those 4 lanes that we're dedicating to that drive, because we don't want to get lanes dedicated to drives that aren't actually being used. So that's another great reason why we want to do that. And that really takes me to the next point here for sustainability. Even though we want you to do really high performance, we can't just throw a bunch of power at it, right? You heard this in the keynotes yesterday between power and cooling and data centers, the point that Lee just brought up about sustainability. Everybody's challenged for carbon footprint and how do you achieve that? So we want to help our customers be able to achieve that in storage so that they can look at this and say, this is one way that our performance per watt can be greatly improved. So going from older technology to a really, really high power efficiency NVMe drive in the future is what we're really targeting. So we really want to see a lot of innovation coming from the industry, both at the NAND level itself and the controller, and how do you really get much, much better performance at much lower power. And I think that takes us to...
Being towards the end here, I guess I can +1 pretty much everything that was said so far in detail. Also, I guess I'll note that our major interests align with a lot of the additions to the OCP 2.5 spec. I mean, we kind of, in the summary that Lee did, just the areas of addition in kind of map almost one-to-one with the kind of the focus areas that we're interested here. I'll start off with security. This is, just core in terms of the trust that, our users place in us, and having that percolate down into, all the elements that were already mentioned here in terms of circularity and sustainability and sanitize issues. I'll kind of put a teaser in. I think there's a security session tomorrow afternoon where we're trying to push on this a little bit. And then so moving on to like scale, this is, we mentioned the FTP addition to the spec. There's just enabling, the growth and the continual improvement of the SSD products that we're able to deploy. And then, back to, at scale, you also have issues with debuggability and telemetry, and that was a huge addition is a huge addition that we've had multiple sessions on, kind of covered as part of 2.5. So I think it's kind of a +1, me too, to a lot of things everybody else was saying here.
And lastly, a few last thoughts here for Meta. Enabling next step functionality is really key to create strong value. We talked about flexible data placement. We've heard everybody talk about telemetry today, the need to data center scaling and how do we debug these things. The telemetry is a huge step forward. Open source SSD qualifications, another huge step forward. These are all big next-gen step things that really add a tremendous amount of value into the ecosystem. So with that, I think it's time for Q&A here.
Howdy. 2 questions. First one, I haven't seen the latest spec. Don't know the whole spec. Are there power guidance in these specs, especially with respect to international stuff? I'm sure all y'all are deploying data centers worldwide and have to conform to local regulations, right?
Yeah, are you talking specifically about the NVMe spec or SAS SATA or both, or?
Yeah, I imagine they both, but mostly
Okay.
I worry about NVMe, but yeah.
Yeah, well, and I assume you're talking like power states. Do we have, we do not have specific power states that have to be supported. That's kind of, we're looking at that as our next, that's definitely an item that we're looking at for our next revision of the spec. We do have requirements in there for around power, absolutely, like idle and things that would have to be met, to try and make things more compliant. A lot of that really is at the system level, but there still are budgets that we give to components, and so like with drives, we definitely have some requirements around power.
That's the thing I'm looking at. Working with specs, power specs that are old and do not contemplate PCI Gen 5, let alone PCI Gen 6, and those sorts of things are showing up. So some guidance from OCP, even some influence on that worldwide power thing would be helpful. Or just gather them up, right? Go ahead, Dave.
Thanks.
Yeah. And I think you're right about looking forward to future PCIe generations. As you make it run faster, it's going to consume more power, and this is going to result in a need to carefully look at what the power limits are in the various form factor specs and what does or doesn't make sense. Unfortunately, it's going to be a form factor by form factor adventure. It's not going to be a one size or one amount of watts solves the entire problem.
So just to close that off, I would ask, as the OCP specs are evolving and everything like that, is bring in the international regulations into that, as you say, one spec to rule them all. It would be very helpful. Second question, SATA calls it device internal state data. NVMe calls it telemetry. Everything that was said about health checks and all that is the OCP SATA spec going to converge on some of these same ideas, human readable telemetry, debug data, all that?
What's your answer?
So absolutely yes. This was something that we are planning on doing a rev of the SATA SAS spec here coming up, now that we've got 2.5 out of the way. And that is definitely one of the items that's on the docket, at least for me. So.
So with that, I see we got a bunch of questions. Let's go to this side of the room, and then we'll come back over here.
Okay, thank you. This question goes to David and Paul. It's interesting.
Can you be a little bit close to the mic? We're having trouble hearing you.
Okay, so this question goes to David and Paul. It's interesting to see that this new thing still goes to SATA and SAS. And the question is, would that require new controllers and a firmware update to support those features that you just talked about?
Can you repeat that one more time?
For the new OCP spec, there's some new requirement on the SATA and the SAS. I don't know whether that also applies to the SSD or just for HDD.
Oh.
If that's so, do we need new controller chip and a firmware update for that?
Yeah, so there's going to be some requirements that definitely apply to both SSDs and hard drives. Are you talking specifically about the security?
Yes.
Yeah, definitely. We want to have, hard drives are huge in data centers. We've got lots of them. We can't just ignore that and say, well, we'll just secure our SSDs, right? That's leaving a huge gap. So yeah, I think from a hard drive perspective, that's going to be a challenge, right? Because hard drives are not, especially like some of the hard drives, I mean, we still ship 10K 2.5-inch hard drives, so there's a challenge there, but I think we're trying to get to drives that we see a long life, so large form factor, 3.5-inch hard drives. Those are going to be around for a very long time, right? We need to make sure to have those secured. So yeah, those are absolutely, we want to make sure that we have the ability to get those secure. We want to support, attestation, authentication to those. Those will likely require new controller chips for those, new firmware. But yeah, we don't want to just say, well, that's a huge portion, but we're just going to ignore that. We're only going to do SSDs. Yeah, it's definitely for both. David, I don't know if you have any other comments?
I think a general comment about needing hardware support for latest security algorithms, particularly crypto, is to the point. When you're looking at firmware validation, you don't have the time to run the secure hash algorithm and software. There's got to be hardware support in it, and that can imply needing a new controller chip in addition to firmware upgrades.
Okay, thank you so much. In this case, do we still need new SATA and SAS SSDs, or it all move to NVMe for SSD?
That's a great question. I think some of that's going to be dependent on the industry and our customers. I know for us, we have customers that have, like I said, we're still shipping some 10K hard drives. I think some of the hyperscalers have a little more ability to push to all NVMe. So I think that we've got to look at that and make a decision that makes sense based on what our customers are still buying. And I know today we're still selling a good amount of SATA SSDs, but I think there are things occurring on the platform side that may change that. And so I think as we start to see the trends, SATA and SAS SSDs are definitely going down. They're not going down in a precipitous way, but they are going down and NVMe is going up. So that's a good trend that we want to see. And I think we've really got to kind of figure out what are the right drives that we want to try and add security to that we think are going to be around for the long haul.
Okay.
Over here, Jonathan.
Yeah, thank you. So FDP, obviously there's a sort of a sure adoption for, in the hyperscale environment because, you can write application, write software that takes advantage of it directly. Is there also interest in enterprise? And then if so, what would be sort of the hurdles or what are the things to tackle next steps to make that happen? Since it's easier to adopt with applications that aren't aware, that transition could be easier.
So you may have heard me ask the killer app question, and I asked it for just that reason. Out there in enterprise, what's going to drive the adoption is the first few killer apps that are widely used and demonstrate substantial benefits from FDP. As those start to emerge, that's what's going to drive the adoption enterprise. We, like HPE, listen to our customers. When the customers say, hey, this is really good, we need to have this, we'll be there.
I would echo that. I think, there are some interesting aspects of it where you've got an ability to just kind of, Lee and I were talking about this just earlier, about, you can just turn it on and kind of leave it there, and for certain environments, they may take a benefit. And as long as there's kind of no harm, no foul, then that might be something that's interesting. I know we're still kind of evaluating that to determine if we just kind of turn it on and put it out there, test it, and then see if customers say, hey, I noticed that there's an improvement here and a benefit, then I think that can help kind of get adoption there. But there's also the concern that you may find a workload that is really bad for it or something. And so I think there's still a little more analysis on our side to determine how that moves forward.
Any more questions here?
Yeah, I have a question.
Yes.
Could you guys comment a little bit on the need for PCI Gen 6 and how soon or what your thoughts are?
Yeah, so I think that PCI Gen 6, for those of you that know me, you've probably heard me say this before many times. I think there's a really great opportunity for PCI Gen 6, not as a buy-for interface, right? It's for now that we've got CXL devices and other things that are sharing those PCIe or CXL lanes, the ability to have PCI Gen 6 on an SSD and maybe only run one lane to that. Now, we still need that to be 4 lanes on the drive because that's going to be backwards compatible. We're going to use that same drive in our previous platforms that are Gen 5 and maybe even Gen 4 because these platforms are revving so quick. And so we still need the 4 lanes on the drive, but we may only hook it up with 1 lane. And so I think that there's definitely a good use case there where we can kind of save PCIe lane usage and have those for some of the by-8 CXL devices we might need in the platform. And so I think, yes, I think there's a great use case there. Still to be determined on what we see from suppliers coming back on what they can do on the high-performance swim lane to see can they, with enough innovation on the power side, can they deliver PCI Gen 6 by 4 performance for a high-performance swim lane drive? That's, I think, still an open question. But I do think on the low end of kind of, again, Gen 6 by 1, that could make a lot of sense.
So right now, Azure, we really don't see a need to go to Gen 6 anytime soon. We've actually extended our roadmap for Gen 5 devices recently. And so, yes, there's the idea of being able to do a lane consolidation maybe, but especially like first gen and things like that, when the technology's new and frankly expensive, we rather just use the good old Gen 5, get the amortization of the Gen 5 interface out of the way before transitioning to Gen 6. So.
I will say that the Gen 6 by 1, that kind of also has some assumptions on what you have on root port capability. And so that I think that that's a that's a capability that we could try and drive in the industry to support that. I do agree with Lee from a cutting edge perspective and making sure that you amortize cost and whether Gen 5 by 2 is good enough as a way to get some lane consolidation, and that's already supported today in almost every root port to be able to bifurcate down. But bifurcating down to by 1 is not supported today, and so you'd have to put a PCI switch, which adds cost, or behind a controller. So I think that there are things that we can look at for where does Gen 6 make sense, and then what is the timing? I think that's a harder question of like, do we need it right when Gen 6 comes out? Maybe not, but I think it also depends on what we have on the host side to support potentially by 1. That's our perspective. But.
I want to pretty much echo Lee's perspective. We're just rolling out Gen 5 now into widespread adoption. Gen 6 is out there a ways, and when we start looking at the timing for that, we're going to be in a somewhat changed world. You saw all of the discussions yesterday about the AI applications and demands they're going to make. And I think that's one of the places to look for where the full potential of Gen 6 is likely to be used. But right now, I think the focus is on the Gen 5 drives and rolling out Gen 5. Okay.
Okay. Any last question here while we have all the speakers held hostage here? Once? Twice? Okay. I guess we'll go to our next talk here. Thank you very much. I appreciate all of you today.